Hello, it's Mrs. Lawler. I just wanted to make a quick video to show you some of the common mistakes that I found in the NetForce lab so that you can make corrections and resubmit them if they are the mistakes that you made. So we'll start with the masses that are placed opposite one another. When you have masses placed opposite one another, there is a force pulling on both sides of the block in opposite directions. So the 1,000-gram mass is causing a force in this direction, and the 1,300-gram mass is causing a force in the opposite direction. Now when you're thinking about adding these masses together, you're really just think about canceling them out. So 1,300 grams is greater than 1,000 grams, so the net force will be in the direction of the greater mass. So this is 300 grams more, so the net force here, the blue arrow represents the net force, is going towards the 1,300-gram mass since it's higher. Now in this example, the student drew two arrows, and it's very unclear what exactly those arrows represent. There is a force caused by the 300-gram mass going this way, and there is a force caused by the 1,750-gram mass going this way. However, the net force is not shown. And since the net force is not shown, I'm not sure exactly what happened in this trial. Like which way did the block go for you? Now I know in my head, because I know that 1,750 is greater than 300, so I know that the net force will go in the direction of the 1,750 gram mass. So this orange arrow here will represent the net force. Now the two black arrows may represent the force of the caused by the two different masses. However, I need to see the net force in your diagram. So you really only need one arrow, and that should be the net force. And the net force is always going to be the direction that the block flew off the table. So this block should have flown off the table towards a 1,750 gram mass. Okay, now let's look at when the masses are placed perpendicular to one another. Now this example here is a common mistake that I received. So the orange arrow here representing the net force is incorrect. Because you must consider all the forces to determine the net force. We have a 1,000-gram mass causing a force in the downward direction. We have a 300-gram mass causing a force to the left. We can't just say that they're not equal, so they're not going to go directly to the corner here. The 1,000-gram mass is pulling greater than the 300-gram mass, so when we put our net force arrow on, we want it to be closer to the 1,000-gram mass. Note that it's still in between the two masses, however, it's closer to the 1,000-gram mass. Now, if these masses were the same, like both of them were 300 grams, then of course it would go directly to the corner there. So what is the difference between a force and a net force? Well, the 1,000-gram mass is causing a force down, the 300-gram mass is causing a force to the left, but those are forces that can be added together to make the net force. So the net force is always going to be the combination of different forces. Okay, and when they're perpendicular to one another, in this case, you don't think about them canceling out because it's not the same as if they were opposite. Now in this example, we have more than two masses on three different sides of the block, and with this pink arrow representing the net force, but that is incorrect. This net force will not go towards the highest mass. You have to consider again all the masses that are causing a force on this block. We have 1,000 grams pulling down, 1,300 grams causing a force to pull it this way in the up position, and then we have 2,100 grams pulling to the right. So a lot of students did put one arrow pointing to the highest mass, but that's not the case because you got to consider these two are also pulling on it. Okay, but this one is pulling more. So when you're putting the net force on, it's going to be in between again. It's going to be in between the gray one and the yellow one, a lot closer to the gray one, like that. So when you're putting the arrow on for the net force, let me make it bigger so it's easier to see, you have to consider all the masses and does anything cancel out? So the 1,300 gram, the 1,000 gram, the 1,000 gram can be canceled out with 300 being left up here, which means we have to consider 300 here and 2,100 here, and so the arrow will go in between but closer to the gray because it has a higher mass. Now on this example, the answer here was a very common mistake that I received from many, many, many students. So if you didn't make any mistakes at all, most of you made this one right here. Okay, so is the answer in red correct? Well, I already told you it's a mistake, so you know it's not correct. This student did use the term net force in the answer, but used the term incorrectly. Okay, so here's what the answer is. The block will move to the left because the net force is greater on the left. Well, each mass does not cause a net force on its own. So we're not going to say that 100 grams is causing a net force to the right and 200 grams is causing a net force to the left. We're just going to call those forces. Okay, each mass causes a force on its own, but that force is not called the net force, because the net force is when you combine different forces. So we have a force going this way, we have a force going this way, but when we combine the two forces, that's when we get the net force. So you can't say that it's the net force is greater to the left. You would say that the force is greater to the left, so the net force is moving in the direction of the 200 gram mass. So just remember that net force is the combination of forces. So when you draw your net force on, it would look like that, going towards the 200 gram mass, since it will cause the greater force. I hope that makes sense to you guys, because that was a very, very common mistake that I received. Okay, I'm going to briefly talk about the relationship between mass and force. We know that we use the formula F equals ma, and in this lab we used a more specific version of that formula, F equals mg, where g is the acceleration due to gravity, but it is still an acceleration. Now, how is force related to mass? Well, mass causes a force because gravity is pulling on it. So we have a combination of the mass being pulled by gravity to cause a force. So we often say the mass is pulling, as opposed to saying the force is pulling, when really it is the force caused by the mass that is pulling the block. So that's kind of why we use those terms interchangeably, because force is based on mass and gravity, and we can convert between mass and force by using this formula here. Okay, here is the last slide that I'm going to go over. I'm trying to keep this under 10 minutes. Forces are vectors. Okay, it's very important for you to understand what a vector is. A vector is a measure that shows both magnitude, which is the amount of force or how big it is, and the direction, which is the way the force is applied, or which way is it pulling. Okay, so magnitude and the direction. Magnitude, size, direction is which way it's pulling. So we have different ways that we're going to draw the arrows. The length of the arrow, so these two are examples of two different forces. The length of the arrow shows how much force there is, the size of the force, the magnitude of the force. So if we're looking at this example right here, and the question is which one is 50 newtons and which one is 100 newtons, we would say that the shorter arrow here would be the 50 newton force, and the longer arrow would be the 100 newton force. And you see that this longer arrow is about twice the length of the shorter arrow. So we represent the magnitude or the size of the force by how long the arrow is. Now, how do we represent the direction? Well, that's the easy part, because it's just the direction that the arrow is pointing. So this force is going down to the bottom left, between the left and right side of the screen. That's the direction where the arrowhead is pointing. Now you need to remember also that velocity, acceleration, and force are all vectors, and they all can be represented with these arrows, which are called vectors, drawn in different ways. I hope this helps, and I hope that you can now correct your lab. If you have any other questions, please contact your teacher, and don't forget to correct and resubmit to the Dropbox. Have a great day.